We live in a world that needs huge amounts of energy in the form of electricity, which is convenient and easy to use. We get this electrical energy from fuels. Fuels are energy stores which can be changed into electrical energy in power stations. Here, the energy stored in different fuels is changed to heat energy, which changes water into steam. The energy in the steam is changed into moving energy when it's used to turn the alternators, and the moving energy produces the electrical energy that can be sent easily, cheaply, and almost instantly to all parts of the country. But using electricity means using up fuels. Each year there are more homes using more electricity. Huge amounts of fuel are used up to provide the energy to move us around, and more cars on the road each year again means more fuel used up. Eventually, the fuels will run out. The main sources of our energy are the fossil fuels, coal and oil, but this was not always so. When the world had a lower population and less advanced technology, the supply of wood, together with wind power and water power, were enough to meet our energy needs. But when the steam engine was invented, the Industrial Revolution created much bigger demands for energy, and these were met by coal. Thousands of men, women and children sweated and toiled to mine the precious coal, and wherever clouds of industrial pollution were seen, it was taken as a sign of prosperity. Coal was king, but only until the first oil wells were drilled. People were so enthusiastic and the wells so big that it didn't seem to matter that everyone was pumping oil out of the same well as their neighbors. A new age had dawned, and oil and natural gas replaced coal as our main source of energy. Some people even thought they would last forever. But as the world demand for energy increased, geologists, the scientists who study the Earth's structure, began to look for oil and natural gas in locations all around the world. And they found it in huge quantities, in North Africa and the Middle East, in North, Central and South America, and in Southeast Asia and Russia. Oil was plentiful and cheap. But a war in the Middle East and huge price rises in the 1970s made countries aware of the need to find their own sources of oil and to make better use of what they had. We could no longer go on pretending that there was a never-ending supply. Conservation was necessary, and our cars are now designed to use less fuel. We're encouraged to use less energy in our homes and offices. New buildings are designed to be better insulated. Waste materials are recycled. For example, it takes far less energy to recycle aluminium than it does to make new aluminium. Finally, hundreds of tons of gravel are dropped onto the seabed about 12 meters below the ice, and a gravel island is formed. The shape of the island is important, and engineers use computers to help design them. One of the problems is how to stop the ice moving in and closing the hole. The design of the sloping shelf causes the moving ice to break up, to stack up, and so form a solid protective ice barrier around the island, which you can see more clearly here from the air. There are severe problems for men and equipment working in sub-zero temperatures, and for 3 months of the year the sun never rises. And when the oil begins to flow, there's the problem of transporting it from the frozen wastes to the oil refineries in the warmer south. But the search for oil is coming to an end, and before very long there'll be no more oil left to refine, and we will have to find alternative sources of energy. Already, scientists are working on 2 oil-related sources. First, there are the tar sands. These are a mixture of sand and a black tarry substance called bitumen. The second is oil shale or marl stone, which contains a waxy substance called kerogene. After the kerogene and the bitumen are separated from the rock and the sand, scientists work out how to extract the fuel, and as a result of their work, large-scale industrial plants have been built. But whether we like it or not, the oil is going to run out soon, and we have to find alternatives. This is a modern open-cast coal mine. Coal has made a comeback. It's the main alternative to oil and natural gas. And today, coal mining is a very different kind of job. Underground in modern pits, machines cut out the coal. It's taken above ground, where it's sorted into different sizes and then washed before being transported to factories and power stations where, once again, its stored energy is being changed into the electrical energy we all depend on. However, in modern power stations and factories, the smoke is filtered, and we no longer see the black polluting smoke and fumes. But we still need liquid and gas fuels in our cars and in our homes, so scientists have worked out ways of getting them from coal. These techniques are going to be important because when the oil runs out, there will still be huge quantities of coal. But not even the coal will last forever. Another alternative source to oil and natural gas is uranium, which is the fuel of nuclear power stations. Uranium is radioactive. People who work with it have to be protected from the radiation because it's extremely dangerous. Radiation can kill. It can cause cancers to develop, and it can damage unborn children. Solid pellets of uranium dioxide are loaded into narrow tubes about 4 meters long, called pins. A number of pins are mounted in a fuel element which provides the energy for the reactor. The big problem with a nuclear reactor is the waste, which is highly radioactive. It can't be used for anything, and it can't be thrown away because it's so dangerous, and no foolproof way has so far been found to get rid of it. Nuclear waste has to be handled extremely carefully, and as a temporary measure, it's stored in specially cooled stainless steel tanks, which are wrapped in concrete. One way that scientists are investigating to get rid of nuclear waste involves mixing the waste with the materials that are used to make glass. The mixture is heated in a kiln where it melts and is then run out into molds. The real process is too dangerous to film, but you are looking at the machine that does the job. When the mixture cools down, it forms a glassy solid. Blocks of the radioactive glass are then stored in vaults deep underground, where they'll have to stay for hundreds of years. Uranium, like coal, will eventually run out. So what we really need to find are renewable alternatives, those that won't run out. The sun is one nuclear power plant that's not due to run out for at least 1 million years or so. Directly and indirectly, it's our main source of energy. Some new houses are being designed with south-facing windows so that they're heated. This is called passive solar heating. Other houses use what are called active solar heating systems. Here, a group of black solar collectors, filled with water, soak up the heat from the sun. The warm water is pumped to a storage tank where it can be used for the central heating system or as a source of hot water. Depending on how sunny a place is, systems like this can provide between 30 and 60% of a home's hot water. In the United Kingdom, we don't really get enough sunshine to rely entirely on this sort of system, but it could be used to top up another system. But perhaps that's a good idea. Perhaps we should use more than one source of energy. Another active solar system converts the sun's energy not into heat, but directly into electricity using these solar cells. Solar cells can be connected into larger units, but they're not very efficient, and convert only 10% of the energy they receive into electricity. They're used in satellites, and down here they may have only a limited or specialized use. Where there is a lot of sunshine, large reflectors can be used to focus the sun's rays onto pipes containing water. The heat from the sun changes the water into steam, which can be used to make electricity. These huge reflectors are in Barstow in California. They focus the sun's energy not onto pipes, but onto a huge boiler at the top of this tower, changing water into steam. There are 1,800 reflectors tracking the sun during the day. It's a pilot plant that's being used by scientists to test out their ideas and to see if it can provide a possible alternative large source of energy. For centuries, we have used the power of the wind to help us do our work. But modern wind machines come in all shapes and sizes, as scientists and engineers try to solve the problems of harnessing the energy in the wind. On a small scale, the Darius wind machine directly turns the shaft of the alternator that produces the electricity. On a large scale, huge propellers with 50-meter blades are used to produce large quantities of electricity. And in places that are known to be windy, wind farms with hundreds of these wind machines are being planned. But what happens on the many days when there's no wind? And would we be better off with smaller individual machines? Another possible alternative source of energy is the sea. Here, scientists are testing a model that uses the energy in the surface waves to make electricity. And this is another test model that uses the movement below the surface. There are many ideas being tested, but so far none has been tried on a large scale. However, one idea that has become a reality is this tidal power station in the mouth of the River Rance in France. Here, the movement of the tide in and out of the estuary is used to produce enough electricity to supply 65,000 homes. But we can't yet rely on the sea as a possible alternative. Falling water contains energy. In some parts of the world, dams have been built to enable us to use this energy in hydroelectric power stations. The energy in the water is first converted into rotating mechanical energy and then in the alternator into electricity. This is the rotating shaft, and this is the alternator. Not all falling water is suitable for use in hydroelectric schemes, and most of the places in the world where it can be used have already been developed. So we can't get much more energy from this source. Geothermal energy comes from the natural heat in the Earth's core. These are geysers. The steam that's formed underground can be tapped by drilling down to it and then piped to the power station to make electricity. But geothermal energy is on tap only in a very few places in the world. Another alternative source of energy comes from biomass. This is the energy we can get from living plants. One way to get this energy is to use the heat from burning logs. In the past, when trees were cut down and trimmed for their timber, no one bothered much about the waste. Nowadays, the trimmings, the offcuts, and the sawdust are collected and processed, turning them into fuel pellets that can be burnt in fires or boilers. A more important use of biomass in some countries is the fermentation of corn, grain, and sugar crops. In the fermentation process, a liquid fuel called ethanol is produced. ethanol can be added to petrol, and so the precious fuel goes that much further. Running our cars on fuel from plants may seem like a good idea. But if the world population continues to increase, a decision may have to be taken between using land to produce energy and using land to produce food. Our present main sources of energy are reliable. They can supply our need for liquid fuels and instantly available electricity, but they are running out. At the moment, the alternatives are renewable, but they're not a reliable source of large supplies of energy for central power stations. What will happen in the future? Will we have to change our way of living? Replay the different parts of the program and use the ideas to help you discuss these problems.